Oh, hello, everyone. So we finished looking at the anatomy of the eye. Now we're going to get into the physiology of the eye, how some of the actions of vision work, and then we'll finish up, of course, with like the problems that can occur. Okay, so first things first. When light waves pass into the eye, they have to be absorbed by something, right? The light energy has to be absorbed, and pigments are great for that. Pigments are simply molecules that can absorb and reflect different wavelengths of light. So think about the pigments in paint or the pigments in clothing. They can absorb different wavelengths of light and they'll reflect different wavelengths of light. Well, the rods and cones in our eyes have different phytopigments that can absorb these different wavelengths of light. When those molecules absorb that light energy, they'll change their shape. When those molecules change their shape, then that causes those receptors to activate an action potential, and so then the action potential gets sent to the back of the brain, to the visual cortex, and then we perceive something. One photopigment um, in particular is called rhodopsin. Rhodopsin is evolved from bacteria that absorb light energy and use that to make their own food. So this molecule rhodopsin has been found in bacteria for a long, long time, for billions of years. It's just that we've taken this pigment and we've modified it to allow it to absorb light energy in our eyes. So we take vitamin A and convert it into this rhodopsin molecule, and then when light strikes this molecule, it changes its shape and causes an action potential. So people talk about, like, eating carrots helps you see at night and that kind of business. What they mean by that is there's enough vitamin A to create the rhodopsin we need to make the photopigment in our eyes. Um, I'm guessing in your diet you probably get enough vitamin A. So carrots in particular are great, but I don't know that carrots are going to be a difference maker for you if you get enough vitamin A normally in your diet. Okay, so now let's get into the path of light as it passes through your eye. Um, when light passes through different structures of different densities, the light will actually change its path or bend. It's called refraction, right? Think through your physics classes. So when substances of different densities have light pass through them, again, the light will bend a little bit. So think about what light passes through. First, it's going to pass through your cornea. Then the fluid in the front chamber of your eye is called the aqueous humor. It's this watery fluid that has nutrients that help supply nutrients to the cornea in your eye. Light will then pass through the lens. Then it passes through this jelly-like fluid in the back of the eye called the vitreous humor. That jelly-like fluid is what holds your eyeball open. And then finally, the light strikes the retina. So think about all those different substances: the cornea, the aqueous humor, the lens, the vitreous humor, and then the retina. The only one of those that can change or is variable is the lens. So we use muscles in the eye to bend the lens, and when you bend the lens, it allows you to change the path of light traveling through the eye so you can focus it. So because of that, we're able to look at something close up and focus on it, and we can look at something farther away and focus on it. So the eye is really spectacular in that way. Now, bending that lens is called accommodation. So when you accommodate, you bend the lens to allow the light to focus on something that you're looking at up close. Um, when light comes into your eye, the rays are pretty straight, and then the lens will bend them. Well, if you look at something close up, the rays are more at an angle when it enters your eye, so it tends to focus a little farther back. We'll look at images to help make sense of this. So that lens is really important as you look at something up close. That's where people can get like eye strain. If you're reading something for a long time, your eyes can get tired. Well, that's because those muscles, those intrinsic eye muscles, have been bending that lens for so long that the muscles get tired. So you can just sort of close your eyes and let them rest. Our eyes are set up for distance vision. Like evolutionarily, our eyes evolved to have the muscles inside the eye relaxed when we're looking at objects greater than 20 feet away. So our eyes are set to look at stuff that's more than 20 feet away, which makes sense evolutionarily because our eyes are set up to notice what's going on far away from us so we can make decisions about what to do before something is close, whether it's something to hunt or something to run from. Being able to look farther out is sort of what our eyes are set up for. Now, If you do have eye strain, if you're reading something, looking at a screen, and your eyes get tired, what you can do is just look up and look out. And if you look at something that's more than 20 feet away, the muscles inside the eyes relax. So, if you're experiencing eye strain, you can close your eyes or just look up and look away, and that allows the muscles inside the eyes to relax. When an image strikes your retina, it's actually flipped upside down and reversed. That's neither here nor there. That's just some additional information. So here's what we're looking at here. If you're looking at something from far away, again, the beams of light, the light rays are fairly parallel when they strike the eye, and then they're bent with the lens, and boom, it lands right on the retina. Well, if you're looking at something close up, the rays are at an increased angle, so then look at the lens. The lens needs to bend more, and if the lens bends more, then it can still focus the light more quickly. So this lens is invaluable to our eyes for being able to look at something up close. If that lens didn't bend very much, then the light would focus behind the eye and your image would be blurry. That's what happens as a person gets older. As people age, you experience what's called presbyopia. Presby means like elder or older. So with presbyopia, the lens, as we get older, the lens gets harder and harder and it doesn't bend as easily. So you have trouble looking at something up close. I've had 2010, 2015 vision my whole life. But now that I've, gotten over 40, my lens doesn't bend anymore. So I have to wear glasses so I can look at stuff up close. And that's just because the lens gets harder as a person ages. All right. Here's just how the image gets flipped upside down and reversed. Again, I wouldn't really worry about that. Just a fun fact. Okay, when we talk about visual fields, we have what's called binocular vision. If you alternate opening and closing your different eyes, you'll see that the image is shifted slightly. So we have these two slightly different images, and what will happen is that some of the wires crisscross as the information or as the axons travel to the back of your eye. Don't worry about jotting down all that information. Just know that you have the retina that detects the light, that causes action potentials, and then axons ultimately carry that signal to your visual cortex where you perceive what you see. When that happens, some of the wires cross and some of them don't. Okay, so I think what's more useful is to actually look at these wires and how they're set up. So here we look at one eye. You'll notice the wires, the axons are in blue. Some of the wires cross over and some of them do not. It's the same with the left eye. Some of the wires cross over and some of them do not. And then we wind up with this overlapping field of view. Now, what this does is it creates depth, right? We can perceive in 3 dimensions. So by having 2 eyes that face the front, think of like a horse or a fish. Their eyes are more off to the side. For us, our eyes are facing the front. So we have these sort of offset eyes that get these slightly different fields of view, and then we put them together, and that creates a 3-dimensional image, which is really useful as we sort of move through space to understand what depth is. All right. And finally, we look at, in terms of physiology, we look at some reflexes of the eyes. With the convergence reflex, if you're looking at something up close, your eyes will cross. Normally, our eyes track in the same direction, but when you look at something up close, the eyes cross and the pupils narrow. Because again, if you're looking at something up close, you don't need all this other visual information. The pupils constrict to allow you to focus on what's up close. So if you look at the image here, the guy's looking farther away. If you look at something up close, you see how the eyes the eyes converge, and then the pupils contract. They get narrower. Let's see. The accommodation pupillary reflex, that's what happens when the pupils narrow. You're also, I'm sure, familiar with the photopupillary reflex. If you've been in a dark room, your pupils will dilate to allow more light in so you can see under dimmer light, and then if someone flips the lights on, the pupils will constrict so that you don't have so much light traveling into the eyes. So that's physiology of the eye. Now let's finish with all the things that could go wrong. Okay. So, of course, we talked a little bit earlier. You have the lacrimal gland produces these tears that help clean the eyes, and the little canaliculi and the lacrimal duct to carry those tears away. Well, inflammation or irritation can cause increased production of tears or blockages of these pathways, and then that leads to sort of watery eyes and the spillage of tears over the front of the eyes. Let's see. Now, there are those different photopigments that absorb different wavelengths of light. If a person doesn't produce a functioning pigment, if a person produces a pigment that doesn't appropriately change shape to stimulate an action potential, well, then you don't see those wavelengths of light. And we sort of lump in those wavelengths with other colors. So that's what we refer to as color blindness. So if certain cones don't change their shape appropriately and lead to action potentials, then we have different forms of color blindness. Or with night blindness, people may have trouble seeing at night, and that can be for different reasons. One could be potentially a lack of vitamin A. So we do have a color vision test that we'll have you guys try out with activities. But this is allowing you to detect what it's like seeing different wavelengths of light. Here's a little video that we've got with color blindness and what the experience is like.
Most of us saw a rush of color when the Bills beat the Jets last night in New Jersey, but others didn't. And it's causing quite the debate online. That's because some fans who are colorblind could not tell the two teams apart. Deadspin posting this video showing what it looks like to watch the game when you're colorblind. The league says it will incorporate a color blindness analysis when designing jerseys for next season. Various studies have found that red-green color blindness, is most prevalent and affects as many as 13 million Americans.
Okay, so you see how everything sort of looks grayed out. Let me look this up. Bills, Jets. So they had what are referred to these as these color rush jerseys. They're these really brightly pigmented jerseys. So here is what the jerseys look like for people without color blindness. And then, of course, if people have that red-green color blindness, then it's difficult to perceive those differences in color. So that's sort of a fascinating example of what the experience would be like if a person has red-green color blindness. Let's see. Oh, okay. These are things that can happen as a person gets older. Again, cataracts. We looked at that video earlier. Cataracts, you can get a clouding of the lens. And a lot of times that happens with accumulated damage due to age. So light will travel in, pass through the lens, and light is energy, right? And energy can break bonds. Well, you can damage those proteins in the lens, and then the lens becomes cloudy, like the eye in the gentleman you see there. It can happen, if you've had a dog, an old dog, develop cataracts. And again, it's sort of like trying to look through a dirty window. The light is sort of sprayed out or diffracted, and then you can't focus light and you have trouble seeing. Glaucoma. Glaucoma can occur if you have increased pressure in the front chamber of the eye. The fluid in the front chamber of the eye, the aqueous humor, it provides nutrients to your cornea. Your cornea doesn't have any blood vessels, right? Otherwise, you'd see like red lines in your field of vision. So your cornea needs nutrients. So the aqueous humor provides nutrients to your cornea, your blood vessel-less cornea. But there's like a little drainage tube. It's called the canal of Schlemm. If that tube doesn't drain the fluid appropriately, you can have pressure build, and then that pressure that builds in your eye can actually damage the retina. And of course, if you damage the retina, the photoreceptors don't work and you don't see as well. So with glaucoma, and if you damage the photoreceptors, then you start to get like a blurring in an image like what you see here, and you might not see something like a person, walking down the alleyway in this instance. So again, that's the sort of damage that can happen with glaucoma. With cataracts, with the light spreading out, you can get this halo effect with lights at night. So, these are a couple of forms of damage that can occur sort of as a person ages, whether it's due to pressure or damage due to light passing through the lens. Hemianopia, this is sort of an interesting one. This is something that occurs if you have damage on usually one side of the visual cortex. If you recall looking at how you have those wires exit the back of the eye and how they both can travel to one particular side, if you have damage to one side of your visual cortex, then you're losing half your field of vision. So with hemianopia, you literally lose half your field of vision. Okay, emmetropia. I don't know how many of you are emmetropic, but with emmetropia, light focuses on the retina as it should, and you've got 20/20 vision. So with emmetropia, you've got 20/20 vision, and you see as one would expect to. Now, of course, many people have light focus in different areas, and that can lead to other conditions like myopia. Myopia is what we call nearsightedness. So in the case of nearsightedness, what happens is either because a person has a long eyeball or a really curved lens, what happens is that the light focuses in front of the retina. So if we look at the image here, if the light focuses in front of the retina, that means by the time the light hits the retina, it will start to spread back out again. So you can imagine here, light travels in, hits the lens and bends, and then here is called the focal plane. This is where the vision is sharp. And then if the focal plane is in front of the retina, then the light will again begin to spread back out again by the time it hits the retina, and what you see is blurry. So people are said to be nearsighted because when light travels in fairly parallel, it will focus in front of the eye and then be blurry by the time the light strikes the eye again. But if you look at something up close, the light rays are more bent and it focuses a little farther back in the eye. So then you can see things up close, but you can't see them far away. And of course, this can be fixed with lenses. Don't worry about remembering convex and concave lenses. Now, the other impact is called hyperopia. With hyperopia, a person is farsighted. So what happens in the case of hyperopia is that a person may have a short eyeball or a lens that's really flat. And because of that, the light tends to focus behind the retina. So we see this image here. The light focuses behind the retina. So when the light strikes the retina, it's still rather diffuse and the image is blurry. So the person's best bet is to look at something far away where the light rays are already sort of parallel so that there's a chance that it can focus by the time it strikes the retina. But they may have trouble seeing much at all. So then again, you can use lenses that bend the path of light and boom, your vision is corrected. So, lenses and glasses are just sort of like a fixed external example of the lens that we have in our eyes, but it allows us to sort of change the pathway of light. So a huge, huge bump up for people. Let's see. Finally, we have a detached retina. The retina is like a membrane on the inside of the eye, but people can experience accidents, like sort of concussive accidents. You get in a car accident or there's an explosion, whatever the case may be. That membrane can peel over, and if the retina folds down, well, then you're blocking those photoreceptors. Imagine like a poster. If you've got a poster up on the wall and the tape peels off in one corner and the poster sort of folds over, and you don't see that part of the poster anymore. Well, if your retina folds over and covers the photoreceptors, well, then you're going to lose that part of your field of vision. So they can try to reattach the retina and things of that nature. All right. Well, that takes care of vision as you work through stuff. If you have any questions, let me know. Otherwise, I hope you have a great day. Take care of those eyes.